Greetings. My name is Murtaza Hirar, and this brief presentation is about regression models being estimated with SPSS, but with a difference. We will be using categorical variables as explanatory variables. As you know that there are two primary types of variables: continuous variables such as age and income that can take any possible value, and then there are categorical variables that have specific values. For example, for gender you can use male or female, or a type of a house. It could be a single family detached home, a semi-detached home, a townhouse, an apartment, or a condominium. Now, when we are dealing with continuous variables such as age and income, either as the dependent variable or as an explanatory variable, we can interpret the model by saying, well, what if the age increases by 1 year? What would be the impact of 1 more year of age on income? And the same cannot be said about categorical variables, because 1 unit increase from, let's say, single family detached to semi-detached does not mean a 1 unit increase, as is the case with age. So categorical variables have to be treated differently, especially when they are being used as explanatory variables. So let's look at a data set. Let's say the dependent variable of our regression model is price of a house. We would like to predict the price of a house, and the prices are listed in thousands of dollars. So the first home is priced at $300,000. It has 4 bedrooms, and the lot size is 6,126 square feet, and the home is of colonial type. So it's the architectural type of the house, and we are looking at whether colonial homes differ in price from non-colonial homes. So we have the lot size, the type of home, and how many bedrooms are there. You may have seen this equation in the past, that a dependent variable y is a function of, let's say, 3 variables. In our case, the dependent variable is price of the house, and the 3 variables are lot size, colonial, and number of bedrooms. Lot size is the square footage, colonial is the type of home, and bedrooms is the number of bedrooms. So beta 1 is the coefficient which will define or advise us how much the price of a house differs or increases if the lot size increases by 1 square foot. All else being equal, which means that if the colonial type of house and number of bedrooms are the same, if the house are of the same type and the number of bedrooms are the same, what would be the impact on the price if the lot size increases by 1 square foot? The same could be said about colonial. Beta 2 would advise us how much the price of a colonial home differs from a non-colonial home, provided that the lot size and the bedrooms are the same. And when you would look at the regression model, you would see that the model will give you the value for colonial home but not for the non-colonial home, or the value for non-colonial home but not for the colonial type. Either one of them would be set as the base case. Now, what about the bedrooms? Now, bedrooms could be tricky. If you look at the number of bedrooms in the data set, you would see that the minimum number of bedrooms is 2 and the maximum is 7, and the number of homes with 6 or 7 bedrooms are just 2, 1 each. So we may want to exclude those from the analysis, and we'll get back to it later. But the variable has 7 categories. So what regression model in SPSS or any other software would do is that it would fix the largest or the smallest, and in SPSS's case, the largest category, which is 7 bedrooms, as the reference case, and then the price of each number of bedrooms will be reported in reference to the largest category. So let's say if we restrict our data set to 5 bedrooms, then the price of a 2-bedroom house would be reported relative to the price of a 5-bedroom house. Then the price of a 3-bedroom house will again be reported relative to the price of a 5-bedroom house. So this is what we mean by using a categorical variable as an explanatory variable. Now, if you were to rely on your garden variety regression model, then you may find that it's a little troubling. This is how the regression model dialog box, the linear regression model, looks like in SPSS. You have to put in all your variables, explanatory variables, as independent variables here. There's no option for you to distinguish between your continuous variables and your categorical variables, and that's a limitation. So to avoid this, I think the golden gem in SPSS is the general linear model, and that gives you, among many other things, the same linear regression, but with many more options. So if you were to use the general linear model, you click on Analyze, General Linear Model, and then click on Univariate, and you will get the dialog box, and we'll get to it in a second. So let's begin by showing you how to get the data and then how we can proceed. You can download the data set from the following website. Visit https://tinyurl.com/hprices. It will bring you to a website, and from that website, if you look down, there's one of the files that you can download is housingprices.sav file. It's only 9 kilobytes, and then click on this down arrow and it will download the file onto your computers. And it's already in SPSS native format. You can open the file in SPSS, subset the data so that we exclude 6 and 7 bedroom units because there are only 2, and then we estimate and interpret a regression model using the general linear model dialog box in SPSS. I will illustrate this in SPSS now. Now we are looking at our data set in SPSS. Notice that we have other variables that we will not be using, but they are there for us. Before we proceed, let's now first subset our data set so that we exclude homes that have 6 or 7 bedrooms. So we say data, subset or select cases. And in the select cases, we say if the following condition is satisfied. So click on if. And here we say the number of bedrooms, and we bring it here and say the number of bedrooms is less than, and let's say 6. So this will give us only those observations where the number of bedrooms is 5 or less. So continue and say okay. So now our data set has been filtered. So those 2 observations have been exempted. And you could see here that this following command has been run. So let's just confirm it. See, there's a strike against this 6-bedroom house, and there's a strike against a 7-bedroom house. So these 2 observations are no longer, will be involved in the estimation of the model. So we have subset our data, excluded only 2 observations, one with 6 bedrooms and one with 7. We click on General Linear Model, not on Generalized Linear Models, but General Linear Model Univariate. And our dependent variable is the price of the house, and the 2 categorical variables will be entered as fixed factors, number of bedrooms, and the type of house being colonial. So that's done. And our continuous variable will be added as a covariate, which is the size of lot in square feet. We will ignore other variables for now. Now, here we have to specify a model. The default is a full factorial option in SPSS. That's not what we want to do. For the simplicity of discussion, to keep it simple, let's just use build terms. Don't use interaction, just use main effects, and then enter these 3 variables to the right side. We are doing this so that we replicate the regression model that you would get from a linear regression model. Main effects, build terms. That's all you have to do. Continue. You're not done yet. Click on options and click on parameter estimates so that the model estimates the parameter for you. When I click on continue and OK, a new output window will open and will show the results. So let's click on OK. I will center it so that you can see it properly. So it will tell you how many units have 2, 3, 4, or 5 bedrooms. 6 and 7 are out now, and about 27 homes were non-colonial while the rest were colonial type. You will ignore the input in this dialog box. Just focus at the bottom and you will see that the adjusted R-square that you get with a regression model is 0.473, which is stating that almost 47% of the variance in prices is explained by these 2 variables or 3 variables, bedroom, colonial, and the lot size. And the parameter estimates are here. And this is your typical regression output regardless of what type of model you use. So it tells you that the base price is $482. However, if it's a 2-bedroom unit, then subtract $254,000 from it. If it's and notice that the 5-bedroom unit has a coefficient of 0, which tells you that if it's a 5-bedroom house, the price is $482,000. If it's not a 5-bedroom house, instead it's a 2-bedroom house, then the price is $254,000. If it's a My apologies. If it's a 2-bedroom house, then the price is $254,000 less than $482,000. And if it's a 3-bedroom house, the price is $234,000 less than $482,000, which is a 5-bedroom house. And if it's a 4-bedroom house, the price is $218,000 less than $482,000, which obviously is the price for the 5-bedroom house. And if it happens to be a colonial type of house, if it's colonial, that's a base case, so it's 0. A non-colonial house would be $5,600 cheaper. And if you look at the T statistics, it turns out that being colonial has no impact. And again, because the T value is less than 1.96, but the number of bedrooms are returning a statistically significant coefficient. Now, the lot size. The lot size is your continuous variable. There's no base case with it because it is a continuous variable. And the coefficient for it is 0.002, which tells you that the price of a house would increase by, this is roughly $2. Because it's in the prices in the model or in the data set is in thousands of dollars. So if I move the decimal point 1, 2, and 3, the price of a house would increase by $2 for every 1 square foot increase in the lot size, right? So at this point 0.002 is referring to the price in thousands of dollars, but in terms of dollars, you multiply this coefficient by 1,000 and you'll get $2. So price of a house increases by $2 for every 1 square foot increase in the lot size. Now, categorical variables, why did we go through all of this? Because in categorical variable case, in SPSS, it holds the larger category as a base case and reports the coefficient for the non-base case. And in this case, colonial has only 2 categories, so it held the larger one, which accounted for or controlled for colonial homes as the base and reported the price difference for the non-colonial homes. And in case of bedrooms, we had types of bedrooms: 2-bedroom, 3-bedroom, 4-bedroom, and 5-bedroom. The model kept the 5-bedroom homes as a reference category and then reported prices or the difference in prices relevant to or related to 5 bedrooms. So a 4-bedroom home is $218,000 cheaper than a 5-bedroom home. I hope this helps. Happy regression modeling to you all.